Hello everyone, today we are going to solve one of the popular question asked in coding interviews, that is finding the kth smallest element. This question has been asked in companies like Google, Microsoft, Adobe and so on, so we can't skip this question at any cost. Alright, so in this video, today we are going to look into the problem statement. There are various approaches to solve this problem and we'll compare those algorithms with one another and we'll pick up one optimized algorithm and write the code in Java. So at the end of the video, I'm going to give a hint to solve one of the popular sorting technique, that is quick sort, with the help of the approach which we have used today to solve this kth smallest element problem. Okay, so please be with me till the end of this video if you don't want to miss that concept. So now let us dive deep into the problem. Given an array and a number k, where k is smaller than the size of the array, we need to find the kth smallest element in the given array. It is given that all array elements are distinct. So what we are given? An unsorted array and the elements are distinct, that is no duplicate element present in the array. We need to find the kth smallest element. As k is given here 3, so we need to find third smallest element. If k is given 5, then we need to find fifth smallest element. What is that? So if I ask you what is the smallest element, that is the first or you can say smallest element in the array, you will iterate through the array and you will find okay, 1 is present, so 1 is the smallest element. Similarly, if I ask you what is the second smallest, so after 1, 2 is there, so 2 is the second smallest. Similarly, the third smallest is going to be, as 3 is not present in the array, so 4 is going to be the third smallest and the output is 4. So this question may be asked in a different way. In interview, they may ask what is the, how to find kth largest element. So here in this array, the largest element is 15, the second largest is 11, third largest is 9 and so on. So you may be asked in either way. So your task today to go through this video completely and understand this concept and try to solve this question of finding kth largest element by yourself. And I'm pretty sure that you can solve that question, because after going through the video you will be having enough confidence and knowledge to solve that question. Okay, so I think you all have tried the problem with your approaches. So now let us look into the solution of this problem. So there are various methods available to solve the problem. I have taken 3 popular methods. So the method 1 is very simple. We need to sort the array, and once the array is sorted, we can return the kth index, and that is going to be the kth smallest element. For example, if the array is sorted, then the first element is always going to be the first smallest and the second element is going to be the second smallest. Similarly, if we are asked kth smallest element, so we will return the kth index. That's it. So the time complexity is going to be order of n log n, because merge sort uses order of n log n. That is one of the best method to sort the array. And to return the kth index, it is going to take only order of 1 constant time operation. So that is about method 1. Method 2 uses a heap. If you are new to data structure or you have not studied about heap, so you can skip this portion, because today we are going to use method 3 in detail and we are going to write the code for method 3. But method 2 is also one of the optimized method to solve the problem. That's why I'm discussing it over here. So in the method 2, what we will do, we'll build a mean heap that is going to take order of n time complexity. And we know that mean heap contains the minimum element at the top. So if we perform extract mean operation k times, then we are going to have the kth smallest element. For example, here in this case, if we build the mean heap of this unsorted array, we are going to get 1 at the top, which is the minimum. So when we perform extract mean operation, 1 will be deleted and it will perform heapification. After the heapify method is called, the second smallest element will come at the top. Similarly, if you perform extract mean operation once again, 2 will be deleted, the third smallest element is going to come at the top. So similarly, if you perform it for k times, then we are going to get the kth smallest element. So the time complexity, as I discussed, to build the mean heap, it is going to take order of n complexity, and heapification, when we are performing extract mean operation, it is going to take log n time complexity. As we are performing it for k times, so it is going to take order of k log n time. Now, if we compare this method with method 1, so method 1 was taking time complexity of order n log n, here order of n and k log n, which is smaller than this, because obviously order of n is smaller than order of n log n, and k, as it is given in question that k is smaller than n, so it is also going to be less than order of n log n. So method 2 is better than method 1. Coming to method 3, we are going to use a quick select method. That is a very popular method and it can solve the question in order of n in most cases, but the worst case time complexity is going to be order of n square. But there are some approaches like randomized quick select method, where it is going to select the pivot element. I'm going to discuss about it in few minutes, that it is going to select the pivot element randomly. So this question can be solved in most cases order of n time, but randomized quick select method will reduce the chances of having worst cases, that is order of n square. It will not make it order of n square still going to be the worst case, but it will reduce the probability of having a worst case scenario. So I will be discussing about this method in detail. So first let us understand what is a pivot element. Pivot element is nothing but element in which the element which are greater than the pivot element are going to be in the right side of the array, and the element which are smaller than the pivot element are going to be the left side of the array. So here in this case 4, if it is pivot element, then you can see 2 and 1 are smaller than 4 and they are on the right to it, and this rest element are greater than 4 and they are placed in right to 4. That is all about pivot element. And please note, pivot element is always sorted in its position. That is, pivot element, if it is k, then it is only the answer, that is kth smallest element. If first element is the pivot element, then it is the first smallest element, because it is sorted in its position. So here 4 is going to be in its own position. It is not going to move at any cost, because 1 and 2 can swap. If we are performing sorting, 1 can come to the first location, 2 can come to the second, and this element can be replaced by one other, but 4 is going to be in its correct own position. So that is what, if it is at kth location, so it is going to be the kth smallest element. So now let us look quick select method in detail. So this method is going to solve the problem in 2 steps. The first step is to find the pivot location of the pivot element. That is, we have taken the last element as the pivot element, and we want to find the pivot location, the actual location of the array, such that the elements which are smaller than this are going to be on its left side, and the elements which are larger than this are going to be on its right side. So that is the first step. And the second step is to compare it with k. If it is equals to k, then we are going to return the value. As I already discussed, pivot element is going to be sorted in its position. So if it is equals to k, then it is the kth smallest element. If it is less than k, so we want a location which is greater than p. So that's why we will shift to the right part of the array. Right part means right to the pivot element, and we will perform this step 1 again. So if it is greater than k, we will shift to the left part of the array, and we will again perform the same operation till we don't find a pivot location which is equals to k. Once we found that, we will return the value k. Okay, so now let us look into the pseudocode. So I know that you are not clear now as of now. So let us look into the pseudocode. Once we will go through it, you will be having the clarity. So we will pick the last element as the pivot element. Yes, 15 is the pivot element. Please note, pivot element can be any first, middle or last. Here I have taken last element as the pivot element in every step. Iterate through the array comparing every element I to pivot element. So we will be iterating through this array with this variable I, and we will be comparing it with pivot element. And j is another variable which is also starting from the first index, and it is going to be swapped with the content of I if the ith value is less than 15. That is the point A. If I is less than p, that is pivot element, swap ARR of I and j, increment j. If ith value is less than 15, we will swap the element, and we will swap the element with j, and we will increment the value of j. Again, I will be incremented because it is in loop. We will check if it is smaller than pivot element, then again we will be swapping the element with jth element. So this is how we are going to perform. This is how we are going to iterate through the loop. What will happen? We will get at the end of the loop, the jth pointer will be pointing to a location such that all the elements which are lesser than the pivot element are going to be on the left side. And after that, we can swap the jth location element with pivot element so that we will get the pivot element its correct location. Okay, so that is the third step, that swap jth array of j with pivot element. So it is going to be swapped with the pivot element, and that pivot element is going to get the pivot location. Alright, so that is the first step. And the second step here is the comparison. We will now compare that location which we got, pivot location, is it equals to k or not. If it is k, then it is the kth smallest element and we will return p. If it is less than k, then we have to shift to the right part of the array, and that right part, the starting index is going to be p plus 1 and last index is going to be end. Similarly, if it is greater than k, then we have to shift to the left part, because we found a location which is greater than. If we want to find the third smallest element, and if we got 5 as the index, so we don't want 5th smallest element. So we have to shift to the left part of the array, and if we shift to the left, the starting index is going to be the same start, but the last index is going to be p minus 1. That is how we are going to perform this operation. So now let us perform this in this example. So I and j initially was pointing to first location. As 11 is less than 15, so it is swapped with I. It is going to be in its same position, and j will be incrementing by 1, and then I will be incrementing by 1, and again we will compare 2 with 15. It is smaller, so j will be getting swapped with ith content. It is again going to be in its own position, and j will be incremented by 1. and in the next iteration I is going to be incremented by 1. So again 8 is less than 15, so it will get swapped, and j will be incremented by 1. I is also going to be incremented by 1 in the next iteration. So 5 is also 15. If you look, 1, 9, 6, 7, 4 all are lesser than 15. So this step is going to happen till we reach 15. Okay, so j is incremented, I is incremented, 9 is less than 15. Again j will be incremented, I will be incremented, 6 is less than 15. Again it will be incremented, 7 is less than 15. Now it has reached to 4. So now 4 will be compared with 15. 4 is less, so 4 will be swapped with its own location. So it is going to be in its own location, and then j will be incremented by 1. It is now locating to 15, pointing to 15, and I will come out from the loop. It is the exit condition. Now pivot element is 15, and the jth location is also, j pointer is also pointing to 15th location. Now what we have to do, we have to perform the swap operation. So once we perform swap, so pivot element is going to be in its own position, because if you look, all the elements which are smaller are on the left and no element is there which is greater than 15. So this is the pivot location. Now we will compare the fourth step. That what it says, first compare it with k. So k value is 3. If you calculate in terms of index, then k minus 1, that is we want to compare it with second index. Is it 2 or not? No, it is 9. So we are not going to return this element. So we have to shift to the left part. How we will shift? We will make the start pointer as the first index, and the last index is going to be p minus 1. So that is what it will come to this index now. So now 4 is the pivot element. Now again I and j will start. I will be compared, content of I will be compared with pivot element 4. It is less, then it will get swapped. 11 is not less than 4, so it will not get swapped, and I will be incremented by 1 in the next iteration. J is going to point to the 11 only. So now if you see, 2 is smaller than 4. So now 2 will be swapped with 11. So 11 will come here now, and 2 will go there. So it is swapped. Okay. So now j will also be incremented by 1. So now it will get compared, 11 with 4, it is greater, so it will not get swapped. Now I will be incremented by 1. 8 is also greater than 4, again it will get incremented. 5 is greater than 4, again it will get incremented. Now if you look, 1 is less than 4. Now j is pointing to 11, here 1 is present, so 11 will come here, it will get swapped, and 1 will go. Now 1 will be in the location 1, or in the second location. So it is get swapped, and j will be incremented by 1. Okay, so now I will be incremented by 1 in the next iteration. Sorry, I will be incremented by 1 in the next iteration. 9 will be compared with 4, so it is not less. So again I will be incremented. 6 is not less than 4, 7 is not less than 4. So now it is the exit condition of I, so it will come out from the loop. Now if you see, j is pointing to 8 now, and 4 is the pivot element. So we will swap the content of 4 with content of j. So now 4 will come here, and 8 will come to the location index 8. So it is very messy. So you can see here I have written all the transformed elements in this array. So 2, 1, 4, 5, these are already written in this array. You can see now 4 is the pivot location, and the index is 2. So now it will get compared with the k value. K is 3, so k minus 1 is 2. So now it is equal, and it will return, and this answer is 4. So I hope you all have understood the concept of finding kth smallest element using quick select method. So we were solving it in two steps. The first step was to find the pivot location of the pivot element, and the second step is to compare it with the kth value. If it is equal to k value, then that is the answer, we were returning it, and if it is smaller than the k value, then we were shifting to the right side of the array and of the pivot element, and if it is greater than the kth value, then we were shifting to the left part of the pivot element, and we were performing the first step recursively. Okay, so that was the concept. If you have not understood it, then please go back and watch the video again, because it is very difficult to understand the code if you have not understood the concept properly. And I am writing the code, that's only because to make you understand each and every line of the code properly. That's why I also request you to write the code along with me. It will improve your coding skill. Okay, so let's start coding. So first we will create class. The class name will be quick select, as the file name is quick select. We will create the main method now. We have an array ARR, which is having the value. Let us copy this content because this example we took for understanding the concept. So yeah, this array is having these values. Let us take the value of k 3 as of now, and let us take another variable small, which is going to refer to the value returned by quick select method, which is going to give us the answer. And this method is going to take array as an argument, k as an argument, starting index as an argument, and the last index, that is nothing but array dot length minus 1. Okay. After that we'll print the value of small. Okay. So let us write the function quick select. Public static int quick select. It is going to take integer array as an argument, int k as an argument, int starting and the end index. Okay. So inside that, first we will be having the value of pivot location. So we will take a variable pivot, and it will be referring to the value returned by get pivot method. So I'll explain it. Wait a minute, let me first type it. That it is going to take ARR as an argument, start index and the end index. Okay. So in the first step, what we were doing, we were finding the pivot element. So this is the step 1 that we will do now, that is so completing the method get pivot, and completion of this method, that is quick select, is going to be the step 2. Okay, it is in reverse order. So the first step is going to finding the pivot element. So we'll write the method for pivot element, that is get pivot. It is going to accept ARR as an argument, the start index and the end index. Okay. So inside it, what we are going to have, a variable, that is pivot element. Okay, and that is going to point to the last index, as we understood from the concept. Now another variable j, which is going to point to the start location. Okay, we will run a for loop where I will be pointing to the start location and it will go till end. Simple, right? So in every iteration, when we are going throughout the array, we will be checking whether this element of I location is less than the pivot element or not, right? So if it is less than, what we were doing there, we were swapping the content of I with j. So we will take in temp, we will store the content of I there, then the content of I will get replaced by content of j. Okay, and then content of j will be having the content which is stored in temp. So in this way, this element got swapped. All right, and after that we will be incrementing the value of j. Why? Because whenever this element is getting swapped, we saw that the j element was getting incremented by 1. If it is not getting swapped, if it is greater, then we were doing no operation, only I value will be incremented by 1. So after the end of the for loop, j will be pointing to a location, that is the actual pivot location, such that the element will be the elements which are lesser than j will be in the left side, and the element which are greater than the j will be placed in the right side. So that's why we will now swap the content of j with the last location. Why? Because last location is the pivot element. Once we will swap it, is going to, the pivot element going to come into the pivot location. Okay, so ARR of end equals to temp. Okay, and then we will return the index j, that is the pivot location. So this is all about the first step. We are taking the pivot element as the last element, j and I pointing to the start location. If ARR of I is less than the pivot element, we are swapping it and incrementing j by 1. And once this we traverse through entire array, we will be swapping the jth location element with the last location with the pivot element, so that pivot element will come to the pivot location. And after that we will be returning the index of j, that is the pivot location. So this is all about the first step. And once we get the index, that is the pivot, once we get the pivot, we were having comparisons, that is the second step. What was that comparison? So if pivot is equals what? K minus 1. So what we were doing, that was the answer, we were returning error of pivot, right? So else, what else? If pivot is less than K minus 1, I'm sorry, pivot is less than K minus 1, then we were returning what? The value, then we will be shifting to the right part of the pivot element. So right part, then we will again calling recursively the quick select method. We will be passing the array reference K value start index. Now it is going to be modified as pivot plus 1, and the last index is going to be the same. Okay, else the only condition left, that pivot is going to be greater than K minus 1. In that case, we will return the same quick select method, that is we are again calling it recursively. There we are passing array and K argument, and here start index is going to be the same because it is going to the left part, and the end index is going to be pivot minus 1. So if we execute this code, I think this will work properly. Let us see what is happening. It is taking some time. Yeah, we got the answer as 4 as an output. Let us take a different example. If we take K value as 5, let us execute it and see the result. If it is 5, then 1, 2 is there, 4, 5 is there, 6 should come. Yeah, we got the answer as 6. So now the code is working properly. So once again, I will go through the code and explain you that first we were making a class quick select, and in the main method we have taken that array and the value K, and we have taken another variable small, which is referring to the content, to the value returned by quick select method. That is what going to be the answer. That quick select method is going to contain pivot element, and if we got the pivot element, that is the step 2, we are comparing it with K minus 1. If it is equal, then we are returning that value. If it is less than K minus 1, then we are shifting to the right part of the array, calling it recursively quick select method, and else if it is greater, we are shifting to the left part of the array. So how we are getting the pivot element? With the help of get pivot method. Get pivot method will first have an element which is pointing to the last location, and j is pointing to the first location, and I is also pointing to the first location, and in every iteration we were comparing it with the last element. If it is smaller than the last element, then we are swapping it and incrementing j by 1. Okay, if it is not, then we were doing no operation, only we are incrementing I by 1. At the end, j will be pointing to the pivot location. That's why we will be swapping the content of j with the last location, that is the pivot element, and we will return the value of j. That is how we will get the pivot element, pivot location. So that is how we are getting the answer. I hope you all have understood the concept and the code. If not, then please go through the video once again. I'm pretty sure that your doubt is going to get cleared. If not, then please post it in the comment below. I'm definitely going to go through your doubt. Okay, and if you are watching this video till now, please hit the like button. So now we are going to see how this concept can be applied to one of the popular sorting technique, that is quick sort. Nothing, it is just like we are calling the get pivot method, that is same as partition method, which is used in quick sort algorithm. Here our target is to find the kth smallest element. So whenever we are getting the pivot element, we are checking it whether it is equal or lesser or greater. So and we are moving to that part, the opposite part. Okay, so in the quick sort algorithm, what we are doing, we are calling the partitioning method again and again, and we will be going to left part and right part, because whenever we are getting the pivot element, we know that it is going to be sorted in its own position, so it is there in its correct position, so no need to change anything about it. So we will be coming to the left part and right part, again we will be using the partition method, and we will be getting a pivot element. So similarly, if we perform it recursively, at the end we are going to get all the element at its correct position, that is a sorted array. Okay, so that is what the concept of quick sort technique. I'm going to make a different video on it, and if you want, you can try it by yourself. Okay, so please don't forget to subscribe the channel and share with all of your friends. Thank you all for watching this video.